It claims that for every positive integer n, the product, as shown, is not divisible by 7. What's the smallest three-digit value of n, which is a counterexample to Kitty's claim? So another way of saying this is, what is the smallest three-digit value of n such that this will be divisible by 7? Because 7 is a prime number, we're just looking for one of the brackets to be divisible by 7. It's not like, is it divisible by 12? And then you might get the first bracket divisible by 4 and the second bracket divisible by 3 or something. It's just going to be one single bracket divisible by 7. Now you could try and do this using brute force. You could sub in n equals 100 and get 501, 599, and a pretty large number here and divide each of them through by 7. It would work, but it's going to take quite a lot of time. So if you want to do it that way, fine. Like it is a solid method and you'll get away with it here because the three-digit value of n is not that big. But if it was, if you were trying 100 and 101 and it turned out to be 112 or something, then it's going to take a long time. So I'm going to talk about a more sophisticated idea, and it's using remainders. It's kind of hinting towards something called modular arithmetic, which you may or may not have seen. It occasionally comes into math challenges, particularly maths Olympiads. It will definitely come in, into more advanced maths. So if you can learn about it, great. I'm kind of still, I wouldn't say I was an expert at it at all. So it's something I'm still working on, but it's got lots of interesting results and allows you to find answers really quickly. And that's what we're going to be doing here. Because let's look at n equals 100 to start with. And I'm just going to do 100 divided by 7. And I'll get 1 remainder 3, 4 remainder 2. Now I can then write down that 100 is equal to 14 times 7 plus 2. That's how you would rearrange this. And from that, I can now work out what 500 is, the remainder is going to be, because I would just times everything through by 5. It would be 5 times 14 times 7 plus 5 times 2. So my remainder would be 10. Now I know it wouldn't actually be 10. I would then take another 7 out and I'd get 3. But the point is, I'm trying to look for a remainder of 0 or a multiple of 7, because then I'll know I'm there. So it's okay to kind of say the remainder is 10, even if even really it's 3. So 501 is going to give us a remainder. We're just going to add another 1 on. So we've got our multiples of 7 here, then you'd actually be adding on 11. So just going to write 5n plus 1 remainder, and so the remainder is actually going to be 5 times 2 plus 1. Just going to write that there, which is then 11. So put a little cross there because that is not divisible by 7. Now I can speed things up. So if I have 6n minus 1, right, I'm going to times my original remainder by 6. That will give me 12. And then, I'm just using this idea here again. And then I would minus 1. So it would be 6 times 2 minus 1. I'm going to get 11 again. Okay, that one doesn't work. This is where it's really going to speed things up. N cubed minus 2. See, because if we had 100 cubed, we would put it into a triple bracket. We could write it as 14 times 7 plus 2 multiplied by 14 times 7 plus 2 multiplied by 14 times 7 plus 2. And if you expand this out, you're going to get loads of multiples of 7. The only number that's not going to be a multiple of 7 is going to be the 2 times 2 times 2. So the remainder is just going to be 2 cubed. And we can use that idea to, get the remainder really quickly. It's just going to be 2 cubed. Wait, let me go up here. 2 cubed minus 2, which is 6. So 100 fails, okay, on all fronts. None of these remainders are divisible by 7. Let's keep going. So now I'm going to go with 101, and I'm going to be doing the same sort of thing. So 7's into 101. I don't even need to do the whole thing. The remainder is going to be 3 now. So now I would get 5 times 3 plus 1 if I want the remainder from 5 times 101 plus 1. And that's going to be 16. So it doesn't work there. It's not divisible by 7. Then 6 times 3 minus 1 is going to be 17. So no. And then 3 cubed minus 2 is going to be 25. So no. So it's still going to take a bit of time, but it's much quicker than doing divisions each time. I haven't had to work out what 101 cubed is. I've just used like that little fact that I showed you down here. Okay, 102. So now the remainder is going to be 4. So 5 times 4 plus 1 is 21. And we can stop. Right, 21 is the remainder, but then 7 would go into that 3 times. So actually, there's not going to be a remainder. 5n plus 1 is divisible by 7 when n is 102. I don't know about the others, whether they are as well. We could look into it, but our answer is going to be 102. Let's just look into it. So it would be 6 times 4 minus 1, which is 23. So it doesn't go into that. And then 4 cubed minus 2, that'd be 64 minus 2, it'd be 62. So I just want to say to finish, yeah, look into these ideas a little bit more. Really, really good. If you have a remainder for a number and then you times that whole number by something, you times the remainder by that something as well. If you are cubing a number, even more powerful, then you end up cubing the remainder or raising to the power 4 or squaring, similar ideas. So great question. Like I said, I think it's a tough one, but if you can kind of use these ideas, you can get there quite quickly. Yeah, really good. Well done.